equations of motion by calculus method. By calculus method. Now we have from the definition of average acceleration, we already know A is equal to dv by dt, right? Therefore, dv is equal to what? Tell me. A into dt. Let us integrate on both sides. So when you integrate, you can at constant acceleration. Okay, at constant acceleration, let us integrate this between initial velocity and final velocity. Okay, so at that time t is equal to 0 and that is at certain time t. And here a is constant. That is acceleration is maintained as constant. Okay. So in that case, integration of dv means what? For instance, we have got already x power n on different integration. What it becomes? X power n plus 1 divided by n plus 1, right? What do you mean by x squared dx? What will you get? Tell me. X power 2 plus 1 divided by 2 plus 1. It means x cubed by 3. So if it is x power x dx, what is that? X power 1 plus 1. Why? Because it is x power 1 divided by 1 plus 1. It means x squared by 2. Got it? Now, if it is dx, what is the value? It means you have got 1 into dx. 1 into dx can be represented by x power 0, right? So x power 0 dx. So in that case, how you can do x power 0 plus 1 divided by 0 plus 1? It means x divided by 1, that is x. So integral of dx is x, right? So similarly, integral of dv is equal to v. And between the limits you have to put, that is u and v is equal to a. What is the integral of t? dt, that is t. Between the limits 0 and t. Now, final minus initial. So, v minus u is equal to, in this case, a into t minus 0, right? Therefore, v minus u is equal to a into t and that becomes 0. Therefore, v minus v is equal to u. You can bring this u this out. So, u plus ut. Hence the formula. Okay, got it? Right. Now let us move to the next equation. That is, what is that equation? S is equal to ut plus half at squared. Right? Okay. Right. Now let us proceed. Take down. Here, we have next equation. Let us target the second equation. What is v dx by dt? Right? Velocity is nothing but dx by dt. Okay. So take this dx that is equal to v into t. Okay. V into t. Now let us integrate between the limits 0, that is x at 0 and x. Similarly here v into dt between the limits 0. So here 0 means t is equal to 0. Because we are working on the variable t only. So this is t. Okay. Are you following? Now let us move to the next one. What do you mean by this? On integration, you are able to get x between the limits x0 and x. Okay. But here, what you are supposed to do, you have got a built-in t is there. So you have to expand it. V is equal to u plus at. So let us substitute this. So here that is 0 and t. Instead of v, you can put u plus at of dt, right? Do you understand? Okay. Now you can expand it further also. Now you can expand the integral like that is this can be 0 t and this you can bring here u into dt, right? Plus and then 0 to t. What about this? At into d, right? Now on integration, it becomes what? U into dt means ut because u is constant. So you can put u, that's all, into t because integral of dt is this one. So put 0 to t plus what about this? You have got a and the t becomes what? T squared by 2, right? Why? Because x power n means x power n means what? X power n plus 1 divided by n plus 1. So in that case, t squared divided by 2, right? And that becomes between 0 and t. Clear? Now let us substitute. So this becomes x minus x0, right? What about this? This is ut because the other 0 is replaced means the entire term is cancelled here. Plus and similarly when t is replaced, okay, so you can put simply at squared divided by 2. And what about 0? When you put 0, everything becomes 0. So this is what is that? 2t plus 8 half at squared. And this is nothing but s, is it not? So s is equal to ut plus half at squared. So this is formula number 2, right? Okay. Now let us move to the next one. Hmm. So in the integral of the KT in how did we do that? This one. First, like, yes, this one. See, that is, you can take this as now our target is this one. Integral between the 0 and t, at of dt, right? So you can bring a outside the integral because that's the constant. So t into dt, right? Between the limit 0 and the t. We have got x. When it is x, x squared by 2. Therefore, a into what is that? T squared by 2. Close the bracket. And between the limits 0 and t. So when you substitute t, it becomes t squared only. So a into t squared divided by 2. And 0 means everything becomes 0. So you can close it. That is why it is a t squared by 2. That I have written as 1 by 2 into a t squared. Okay. Right. Then let us move to the next one. That is uh, acceleration. What is acceleration? Now we are moving to third one. Now tell me what is acceleration? A is equal to dv by dt. Okay, right. Now what you do is this dv by dt. Now this can be what? That is multiply and divide by dx. Okay, multiply and divide by dx. Do you understand? Right? Why did you multiply? Multiply and divide. That's all. Why? We are going to do some gimmicks. Okay. And now you can bring this as dv by dx, right? Okay. Into the remaining dx by dt. Got it? Done. So it means this dx by dt is nothing but v, right? So I can put comfortably v into dv by dx. Okay. Now I have got 8. So bring this a dx to the left side. So this becomes a v dv. Our objective is the similar elements should be brought at one side. So that is the very idea. Okay. Now this is a dx. Of course, a is constant. You need not worry about it. Now integrate between the limits. Okay. So integrate between the limits. So here x0 to x, right? What about this? U to v. Okay. Initial minus final, right? Therefore, a into what about this? This becomes x between the limits x naught and x, right? And what about this? This is integral between the limits v dv means v square, right? Divided by 2 of u and v, right? Okay, are you following? Right. Yes. Now, yes. A of that is x minus x0, right? The left hand side, final minus initial. That is equal to this one. That is a v squared divided by 2 minus u squared divided by 2. Okay. So let us take the LCM v squared minus u squared whole divided by 2. Make it common. And a, this is yes because x minus x0 is equal to yes. So bring here. U squared, you have got the final minus initial. So you have to substitute the value of v in place of v minus substitute the value of u in place of v, right? Final value to be substituted and the initial value substituted. Then it will be subtracted. So this becomes 2as is equal to v squared minus u squared. So it means v squared minus u squared is equal to 2. So likewise, we can make use of these formulas, I mean calculus method for deriving these kinematic equations. Okay. And in this case, you should know something about the non-uniformly accelerated motion also. But it is beyond the scope of your syllabus. Even then, I'll try to touch upon certain aspects. Take down non-uniformly accelerated motion, right? So here we already know V is equal to ds by dt. That is number one. Number two, that is A is equal to, we said dv by dt, right? dv by dt. And as I already mentioned, this can be multiplied and divided by dx. So this becomes a dv by dx into dx by dt. Okay. So in that case, what we have done, dx by dt is equal to v, therefore dv by dx. Okay. Right. So this is another set of equation. Third one, and the displacement from here, you can call it ds is nothing but v dt. So these are all various interpretations. Then fourth one, we have dv by dt, which is nothing but dv into a dt. Okay. So that is nothing but v dv is equal to a dx. Why? Because this a is equal to dv by dx, right? So in that case, you can introduce dv by, that is dv is equal to, instead of a, you can put dv by dx. Okay, right? And here, once again, you can, otherwise you can take like this, a and v into dv. That is, I have taken dv and this is as dv by dx. So dx by dt is once again v, is it not? So dv, what about this one? This is dv by dx. How is and a dv by dx? A is equal to dv according to this. Change of, we have done this exercise, that is a is equal to dv by dt. dv by dt. A is equal to dv by dt. So we take this dv by dt, and v is nothing but that is we can go ahead from this. For instance, v dv is equal to a ds, and a is equal to v into dv by dx. Okay, which is nothing but here. Are you able to follow? So I have taken from here. Okay, right? And so these are the that is acceleration of a particle is not constant. That is acceleration as a function of time. So when it is not constant, you have to maintain as such only. And in that case, you cannot take the a as constant, and you cannot take outside the integral. But that is another scope. But even then, you should be able to know at least up to this extent. Okay, so it means for when a is not here, I would have done like this. I would have put a as constant here, right? Somewhere. See, so I've taken a dx means a as constant. But in non-uniform acceleration, you cannot take a as constant. So you have to again put a and substitute a, and for which these equations are useful. Okay, are you able to follow? Clear? Yes, sir. Okay. So, but I'm not going further on this topic because it is beyond the scope of your syllabus. Now, let me solve some problems so that you could be able to answer some questions. Take down. Two particles move along. Two particles move along x-axis. Two particles move along x-axis. The position of the particle is given. The position of the first particle is given as x1 is equal to, let us mention this as x1, 6.002 squared plus 3 point, when it is given, you know about the significant figure. So what is the significant figure here? 3. Here, 3. So 3t plus, so if it is given like this, you are supposed to maintain the same values, significant figures. Then these all are given in meter per second. The velocities are given in meter per second, and the distances are in meter, and the time is in second. Okay, right. Now, acceleration of the particle too, second particle, it is given as acceleration. Let us mention this as at. Acceleration of the particle 2 is given as a minus 8.00 t. So this is given in meter per second square. T is in time only, second. At t is equal to 0, at t is equal to 0, its velocity is 20 meter per second. 20 meter per second. When the velocities of the particles match, so velocities of the particles, that is the v1 and the v2, they match, find their velocities. Okay, so this is the question. Okay, now let us proceed. Listen, let us list out the parameters are given here. What is the x1? This is the first equation. x1 is equal to 6. 0.00 t squared. So we have given this one. And particle 2, A2 is 800 meter, 800, not 800, 8.00 minus 8.00 meter per second square. And what is the V2? That is 20 meter per second. Okay, 20 meter per second, and that is given at the t is equal to 0. Okay, right. And what is its velocity? The velocity is 20 meter, that is given clearly. And now let us proceed. So what we are supposed to find out, we have to find out the V1 and the V2. Take down. What is velocity in terms of calculus? V of t at the t is equal to ds by dt, right? Here dx by dt. Okay. Now let us differentiate the first one. That is, we want to find out the V1. So what is V1? So the V1, what is V1 here? Tell me. 12.002. So that is V at the t. Let us put V at the t is equal to 12.00 into t plus 3.00. 3.00 plus 0. So because constant. Okay. Right. So this is the V at the t. Right? It means 12t plus 3. Okay, right. Now let us proceed with particle 2. Particle 2. Here, the acceleration is given. What is acceleration? Acceleration, in terms of acceleration, they are given. Okay, so in that case, we can take acceleration at the t at certain time into dt. Okay, is given as v of t. Okay, v at that t. Okay, v at that t, because u is equal to 0, so we have taken v is equal to u plus at. Okay, so instead I have put like this. Now we have, this is a very important equation. Now we have to integrate it. So integrate. Okay, so on integration, now that is a v, it becomes t, v at t only. Okay, so this is vt. This vt is equal to, listen to me, now integral between the limits. What is this a acceleration? 8 point minus 8 point 8.00, okay, into dt, right? Into dt. And here we take actual, I think there is no integration here. V of t is equal to a into dt. Okay, no integration on the right side. So I have just taking the reverse. So interchange the RHS and LHS. So V of t is equal to a at t. Instead of a at t, I have introduced this 8.00. So 8.00 into dt, right? So it means can we say dt is equal to integral of t? 800 into t. I left the t. I have to put this t. Let me rewrite. Vt is equal to integral minus 8.00 into t into dt. Okay. Right? A into. Now, taking outside the integral being the constant, so 8.00 of t into dt is equal to v at t. Okay. Now, this is equal to minus 8.00. And what is the integration of t? T squared. 2. So you can put t squared by 2. Okay. And since there is no, what do you call it, integral limits given, you have to put the integral constant c. So in indefinite integrals, you have to introduce this c. Okay, what do you call it? Integral constant. Okay, so whenever you integrate the indefinite integral, that is integral without limits, you must always introduce this integral constant, that is here is called c. Head of. Now v at t is equal to, what is that? 2, 4. So 4t squared, right? So minus 4.00 t squared. Okay, is that clear? Plus the integral constant, this one. So c, right? So as I have already illustrated, we need to evaluate this c. So to evaluate c, take down, to evaluate c, make it t is equal to 0. Okay, 0 second. And find out the value of c. Are you able to follow? Now, this v at t is equal to, this becomes a 0 plus c. It means, what is v value? We have taken the v value here, that is 20. So at the t, okay. So it means that is 20 meter per second, that is equal to c. Now we have found out the value of c. And based on that, we can work out v at the t. Okay. So now v at the t is equal to, what is that? That is minus 4.00 t squared plus, what is that? The c value is 20. So you can put 20. Are you able to follow? And this at t means that is the v2, is it not? Second particle. Okay. So in that case, now let us bring about this v2 of t is equal to minus 4.00 t squared. Is it not? So t squared plus 20. And what they have given here, v1 and v2 are matched. They are equal. Okay. So in that case, now you can find out, we can match this, we can compare this. Therefore, V1 at t is equal to V2 at t. Do you agree with me? Okay. So V1 at t means, what is the initial value? That is 20 plus 3. Is it not? And a V2 at t means how much? What was the value? 4 plus 20. Minus the 4t squared. 4 squared plus 20. Okay. Now you can bring t squared here. So plus 4t squared plus 12t, and this 20 becomes what? Minus 7 is equal to 0, right? Now you can apply the quadratic formula. What is quadratic formula? T is equal to minus b plus or minus the whole square root of b square minus 4ac divided by 2a, right? Entire 2a. Now what is a here? 4. B 12. C minus 70. Now you can substitute accordingly. So what is that? 4 into, t is equal to minus, tell me, 12 plus or minus the whole square root of b square 144 minus 4ac. 4 into, what is a? 4. 4. What is c? 17. Whole divided by 2 into a, that is 4. Now tell me, minus 12 plus or minus the whole square root of 144 minus how much? Yes. 16 into 17. It will be plus. Yeah, plus 272, right? Yes. Okay. Yes, sir. Minus 4 into, I must put minus 17, right? So it means plus 272. Plus 72 means 144 plus 272. How much? 6, 1. Then 3, 4. 4, 1, 6, right? Okay. So it is 416 whole divided by 8, right? So that is minus 12 plus or minus the whole square root of, what is that? 4 plus 2, 6, and then 11, balance 1, 3 plus 1, 4, right? 416, okay? Divided by 8, right? So that is equal to what? T. That is the time. Now you have to find out the 416. Do you know the division technique of square root 2? So we find the rest. You know the root of 416 by division method. You don't know. So the total, I don't remember. Okay, I'll teach you. So 416. So in such cases, for obtaining the square root by division technique, you have to take two digits from the right. Okay. So two digit and this ends up in single digit. So 416. Now, what is the simple square between these four? Two twos are four, right? Then drop this 16, okay? And multiply this by 2, 4. Now you have to find out how many times it comes. 4 fours are. No, you have to multiply, that is, two twos are 4, and it won't go, okay? So put 0, right? You can make it as a 40. So put 0. Because when you put 4 means you have to, I will do one thing. Let me take the simplest number. Let me take 625. Okay, take this. So two twos are how much? 4. Balance 2. You drop this 25. Right? Okay. Now 2 into 2, how much? 4. So you have to select the square numbers only. For example, I can take 5, 5. So it becomes a 5, 5 is a 25 and 225. So you can declare square root of 625 as 25. But in this case, now I have dropped to 16, but it is already 4. Means when I take one minimum, I should have 41, right? Are you able to follow? Minimum number is 41, so it is less. So what I am doing, I cannot operate with this two digit. I can draw another two digit. When I drop two digit, I have to put 0 here. Okay. Now I have to multiply the same number. Whatever the number you put should be reflecting here. So shall I put 4? What is that? 4 fours are 16, balance 1, then 1, and 4 fours are 16. So it won't go. Then we are supposed to do with the 3. So to 20.3. So 3. 3 threes are 9 and 0. Then 3 fours are 12. Okay. So we can stop with this. Now you can declare 20.3 is the square root. Therefore, minus 12 plus 20.3, 8. Okay. You refer my video where I have, done lot of such some based on the division method for square root. Okay. You can easily understand that. Even after watching this video, if you are unable to understand, then I will teach you. Okay, because I don't want to waste time here, right? Otherwise, it use the calculator and proceed. So t is equal to minus 12 plus or minus 20.3. Okay, then divided by t, that is 8. So it means minus 12 plus 20.3 divided by 8. Another answer, minus 12 minus 20.3 divided by 8. So what is that? What about this? Tell me quickly. 3. Then 10 minus 2, 8. So minus 8.3 divided by 8. Another one here, minus 32.3 divided by 8. So these are the two values. So here the time is in negative. Okay. So in that case, the time cannot be negative. So we take the what? The modulus value. So t is equal to modulus of 8 minus zero point 0.3 divided by 8. So it becomes 8.3 divided by 8. Similarly, 32.3 divided by 8. You understand? And in order to find out, now we know the time. Based on this, what we are supposed to do, you can substitute these two values in your original equation. What is that original equation? You have got Vt, V at t, take down V1 at t is equal to, what is the first equation? 12 into this one. Okay. So you can take up this one. 12 into V at t means 12.00 into what is the time? T. That is T. What is the T value? The T value 8.3 divided by 8 means that is roughly 1.04. Okay, correct. And what about this one? Divided by 8, 32.8. How much? 4.04. 4.04. Is it 4.04? Please check. 20.3 plus or minus, okay. This is minus 12, okay. 8 minus 20, okay. Now tell me, what is it? 4.04. Oh, minus 4 point, we make it as a plus 4. So 4.04. And 4.0, yes. Now you can substitute these two values here. So one is with 12 point, the t value. Okay, so what is the t value? 1.04. Huh? I'm sorry. Yes, sir. For this, we cannot take the negative value. We have to take only the positive value. So please, 1 minute, 1 minute, 1 minute. So what is that the t value? So we can take only one value. Yes, sir. Yeah. So this comes in positive one. Is it not? 20 plus positive. So this you are able to get positive value. And here it is negative. Time cannot be negative. You can neglect this, ignore this. So we take only this value. So 1.04. Okay. So the time value is 1.04. So 12 into 1.04, then plus 3. So that is equal to how much? 12 into how much? Calculate. 12.48 plus 3.00. That is 7.48. So 15.48 meters per second. So this is of V1. For V2, you got another equation. That is minus of 4 t square. Is it not? Plus that 20. That is V. Okay. So it means a minus, what is that? 4 into 1.04 the whole squared plus that velocity is 20. Okay. I mean, that t. What is that t? Is it not right? So, what is that value? Minus 4 into point 3 is equal to how? You can use calculator. What is the final answer? Minus 4.33. Yeah. What is the final answer? Um, 15.67. Okay, so 15.67 meter. Good. So now we have got these two velocities at certain time. Okay. This is almost closer to each other. Okay. Yes. And finally, I'll be discussing about the equations of motion. So we have a doubt in this. Now I will finish, then you can ask me. Let me finish. Then equations of motion for the object under gravity. Take down. under gravity, under the influence of gravity. So in that case, how you can interpret the equation? Tell me the original equation. V is equal to U plus 8t. And what is the second equation? V is S is equal to ut plus half at squared. And what is the third equation? V squared minus u squared is equal to 2as, right? Now we can replace this a by g, okay, plus or minus g, based on the ascending or descending bodies. Then, and s is replaced by h, that is the height factor. And then for okay, h replaced. That's all. Now I can put once again, that is instead of v, now v, right? And then u, right? And then instead of a, you can put plus or minus g into t. So this is the formula for gravity. And second, s is replaced by h, and then ut plus half, and here plus or minus g into t squared. Okay. Then third one, v squared minus u squared is equal to 2 into plus or minus g into h. So you must remember the set of equations, and you have to note down one thing. For example, when the object is moving upward, okay, take down. When the object is moving upward, the acceleration due to gravity is taken as positive, is positive. When the object is moving downward, the it is by convention, that is the g is taken as negative. Okay, so remember. And suitably we can substitute. For example, when you are asked, find out the height traveled by the by a stone which is thrown upward, what you are supposed to do? Yeah. Thrown, body is thrown upward means. Plus it's going against the gravity, will it be negative? Which one? Huh? If it's going against the, so it should be negative. Which one? G. You said G when it's going upward is positive, but should it negative? This is by convention. I will explain when I explain about the vector related to this one. Okay. Then, so here the it means that is when you say that is G is a positive means by going upward. Listen to me carefully. By going upward, the gravitation force will be going on increasing to pull you downward. Do you understand this meaning? Are you able to follow? When you go upward, when the body is thrown upward, let us talk about this a body which is kept at zero, ground level. When the body is kept at top level, say about H, okay? Now what happened? Where the gravity will be more? It is something like that is when you chase it. I mean, the dog will be very much interested when you are running away, right? Okay, it will apply more force on you. Likewise, when you are going away from the earth, the acceleration will be more on this. Are you able to understand this? Okay, so that is the very idea, right? But what you have mistaken is the your acceleration is getting retarded. Do you understand? Got this point? Your acceleration is getting retarded because its acceleration acting upon you is increasing. Correct? Right. And that is why you can safely listen. When you wait, when you walk on ground, you are safe, right? When you walk on ground, you are safe, right? When you walk on a rope which is kept at 5 meters. That is risky, you know. Why? The earth will catch you. It is aggressively acting on the higher objects, which is flying above. It is something like an ego, you know. So when I am compatible with you, you are very comfortable, right? But when I touch your ego, when I teach you, and your aggression will be more, right? Something like that. So earth is also behaving like this. When you go against earth, it will catch you once again very instantly. Got this point? Okay. So that is why by convention, when the body, the G should be taken as a positive when it is going upward. It means acceleration due to gravity is going on increasing. It will try to pull you down. Okay. So likewise, you have to understood. But in this case, that is, you are almost falling freely, you know. Okay. So here it is just opposite. And that is why it is taken as a negative when the body is moving downward. But I'll be able to explain in a better way when I discuss the vector, right? Okay. Then, um, for example, even now I can explain. See, that is, you are moving in a train, right? It is, say, about 60 kilometer per hour. Okay. And another train, it is coming in the opposite direction. Okay. Do you understand this? And that is coming at 40 kilometers per speed. But when this train crosses, you can find both the train is apparently moving fast. Have you ever noticed this? So it means these two things will be added and it becomes the relative velocity will be 100 kilometer per second. That is why you are able to see the high speed on both sides. But let me take like this. This is 60 kilometer and this is also 60 kilometer the same direction, right? In the same direction. Okay. Now what happens here? As the two trains are static, stationary, okay, the relative velocity will be here. That is, VR will be zero. Do you know why? Because they are adopting in the same direction. So this is the case happening here also. For example, when there is any head-on collision, there is a road and there is a car moving like this. Okay, so if there is any head-on collision, the impact will be very severe, is it not? Because they are moving in the opposite direction, right? Okay, so this is at 60 kilometer per hour. This is at 80 kilometer per hour. But the impact will be what? 140 kilometer per hour, right? But at the same time, let me consider we have got two roads, and on one road, one car is moving like this. Another car is almost overtaking without disturbing it. Okay, and it will have the relative velocity. Say about this is 100 kilometer, and this is 60 kilometer. So at 40 kilometer change will be taking place here. Okay, right? Oh. So I think when I discuss about the relative velocity and vectors, probably you can understand better also. Okay, right. Now, I hope now I have clarified this doubt. Any other doubt?
We are saying gravity, acceleration, gravity, positive attitude, and instead of identifying the molecule upwards, then won't it deaccelerate? Because the gravity is a movements.
When you say acceleration due to gravity, it is not the acceleration possessed by you. It is the acceleration possessed by the earth. Do you understand this point?
Okay.
Okay, so when you say G, so I am the earth, you are going away from me, means that is, I will be more aggressive to attract towards me, right? But when you are comfortably coming towards me, why should I be aggressive? Do you understand this point?
Gravity is not.
Yeah. So gravity is something the attractive force possessed by the body. So in this case here, you should not mistake that your acceleration. Okay, right? Then equations of motion along smooth inclined plane. So this is another concept. Take down. This is the write down equations of motion along a smooth inclined plane. Inclined plane. This is a smooth plane. Now let me consider this is the inclined plane, inclined at an angle theta. Okay, and this is the vertical height that is BC. Now the inclined plane AB is at an angle theta. Now the object is here, and from here this is a vertical thing, and here, so if it is theta, and let us draw another angle like this at the same angle. This is also theta, same angle, theta. And here you have got the, I mean, from here you can draw another parallel line like this. Okay. And this is also equal. You can put this as a dotted one also. Okay. Right. So you have two vectors, that is O to G vector, and O to here there is another vector, you can put E also, and O to this is the O to A. Okay, so I have drawn a parallelogram like this. Okay, now this vector is the one of the components of the middle vector. So it is called, this is the vector, that is this vector is G vector. This is the acceleration due to gravity. It vertically applies on the body. Okay, acceleration due to gravity is applied vertically. This being a vector, this can be resolved into two vectors as but I mean component of vectors. So generally component of vectors can be resolved into horizontal component and vertical component. And the vertical component on this side can be, that is G sine theta. And the horizontal component here, it is called G cos theta. So I'll be able to explain in a better manner when I discuss the vector. But take it for granted, at least the labels. Okay. Now, the object is sliding down from B to this position and reaches A, that is to the ground. And so AB is the inclined plane, and the axle, we are checking the acceleration of the object, that is O. Okay. So if the object falls freely downward, okay, object falls freely downward, the acceleration of O is less than G. Okay, take down the acceleration of the object, take down AO means object. So the acceleration of the object, take down, the acceleration of the object is less than G. Okay, less than G. When the object freely, when the object freely falls, that is falls freely downward. Okay, so this is one condition. And second, the acceleration of the object is sliding down and in the plane of G sine theta. So this inclined plane is called, take down, inclined plane is called G sine theta. So the vertical is taken as G, and the another component is called G cos theta. Okay. Now, based on that, we can redefine the equation of motion. Actually, there is a separate derivation for that. but in your syllabus it is a limited one, and we'll be discussing in detail under vector. Okay, but to start with, we can have what is v is equal to u plus at, is it not? Now can you substitute here? So what is v? V is equal to u plus, instead of a you can put, it is coming along g sine theta, so you can put g sine theta, g sine theta into t. And second formula, s is equal to ut plus of what is g, a g sine theta again into t square of a t square. Instead of a t square, you can put this one. And what is v squared? V squared is equal to u squared plus 2a is 2 into g sine theta into s. So you can consider only this g sine theta. Just remember a is equal to g sine theta. And replacing this, now you will get the complete equations of motion along what? Inclined plane. Now let us make it opposite. That is, now it is going to climb up. Okay. So in that case, how we are going to do? We are going to introduce this as minus. Okay. So here a becomes, that is, minus g sine theta. So in that case, now put down acceleration. Now we are discussing the body. Take down body moving upward in an inclined plane. You understand? So in that case, acceleration acts like minus g sine theta. Now we can substitute. What is the first equation? V. Tell me. U plus at, and here minus g sine theta. Put always a bracket like this into t, because you may get confused. Sine theta t means sine of theta t. So you do not confuse with that, and that is why I am putting the bracket here. And what is 2? That is second one. Tell me. Yes.
This is equal to ut minus half
Half
sine
t sine theta t squared. Very good. Then third,
v square is equal to u
v
square
squared is equal to u squared minus 2 into
g sine theta
g
into
sine theta. What is that?
into
As into s. We have put like this. Okay. And the final concept is feeling weightlessness. And you will also feel weightlessness after finishing this chapter. Take down feeling weightlessness. Right. See, feeling is not a case of free fall. Actually, no force acted on us, since we are not able to feel our weight. And we feel our weight due to the reaction we get from the earth. As in free fall, we are not putting anything. So we are not getting any reaction. Do you understand? For example, this is the earth. When you climb up, right, you are pushing the earth and going forward. And that is why the earth will be angry with you and it will try to pull you down. Got it? Why you are going against me? Then it will topple you. So it means we are disturbing the external force. But when we are freely falling and there is no force acting upon us, it means we feel the weightlessness. And that is why you got this great giant wheel, where we will be playing, and that is, you will be hanging here, 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 here. Okay. When you go up, right? When you go up, nothing will happen. Okay, you are not worried. You will be enjoying, crying like anything. But when it comes down, you may feel as though your stomach is coming out of your mouth. Is it not? Do you know why? Because you totally lose your weight, right? You can experience that. That is a different experience from the normal movement, and that is why you would have felt this weightlessness even during the descending of lift. Have you ever seen when the lift is coming down very fast, then you can feel that what the weightlessness. So this concept should be studied at the end of this session. And anyway, that is, we'll be discussing in detail under gravitation as a separate topic about this, where I'll be adding more important things. Ah,
Using that equations under gravity. So when like throwing ball up, so u is equal to initial velocity is zero or final like initially so we'll have velocity, right?
no, how can you say initial velocity is zero? You are pushing. So that is the initial, you have got some initial velocity, say about a 10 meter per second. After throwing, it reaches a V. That becomes zero.
So v is zero when it is at the highest point.
Yes.
Okay, and when it's coming down, then v is higher is equal to v, but
Exactly.
so,
In that case, V will be higher when it reaches the ground. And that is why it comes with the maximum impact and it gives the maximum damage. For example, when you consider the projectile, when it is projected, you need some force. But for falling, it will fall. Just like because of the force, it has reached the maximum height. And that is why we study when the object is when the object has reached the maximum height, the final velocity will be zero instantaneously for the short while. After that, it has to come down, no? So immediately it picks up the velocity, right? Okay, so that we will discuss under projection in the.
that is the question we get.
Hmm.
So, to particle below x-axis question we were doing, we use the formula K dt is equal to V T, and we did integration of it. How did that come?
18? Yeah, that is the standard formula you must remember. You have to remember that one.
Okay, but then VT, okay, which
That
VT giving us the second velocity. So what that V at t seconds.
Vt means it is not V into T, V at T.
Oh,
Okay?
V. Oh,
So we will continue tomorrow.
particle as well.
Fourth, only we have discussed two particles.
So we use that